Hello, it's Duncan with more of our look at implementing the Gilded Rose stock control system with test-driven development in Kotlin. Here are the stories we've got from our customers so far, and if you've been following along you'll see that we've got as far as this last story, but this we haven't implemented at all. And what our customer has told us is that when they view the stock in a browser it should update the qualities, and that the updating quality is going to be complicated because of all these magical items we've got lying around, but for now we can just get away with reducing the quality of each item by 1 every day. Thinking this through, we realized that in order to reduce the quality of each item by 1 every day, we're going to have to know when the stock was last updated. And so today we're going to look at loading and saving the stock list, including when it was updated. At the moment, that's not what we do. At the moment, we just load a stock list from disk, but we don't know when it was last updated. So let's remind ourselves of the code. We have some tests here. We have persistence tests, and we have persisting, which is where that code is implemented. And you can see we've got the ability to load items from a file and save them to a file. And at the moment, the production code doesn't actually save items at all. It simply loads them because our customer has been editing this tab-separated file themselves. So what we're going to want is some sort of data structure that contains both the items that we're currently loading and the time that they were last updated. And that we will make a data class, and we'll call it StockList, and we'll just put it in here for now. And this should have two properties. One is it's last modified, which will make an instant because that will be independent of time zones or anything like that. And the other thing is the items, which as currently is a list of item. If we had that, we could return it from load items, which currently returns a list of item. We could say this is going to be a stock list. And in order to make that work, we create a stock list in here where the items is the thing we're currently loading, and the last modified. What can we use? Well, we've got no idea at the moment, so let's just use instant now to put something in there to get it to compile. Now, if we now run our tests, we'll find we can't because we expect to be able to produce a roots on a list of item, and stock is now not a list of item, but we can solve that problem by having our stock list implement list of item. And we can delegate to the items inside us. And that will allow our entire app to run and our test to pass. Our app compiles at least, and our test to pass. It's interesting that it does pass though, because here you can see we are saying file load items and then assert equals stock. This stock is a list of item. So it's interesting that in this case, this list of item considers itself to be equal to a stock list. But if we were to reverse this, our test would fail. And that's because our stock list is not the same as its list of the items inside it, because it's got this last modified. So what we really want to be able to do is say, once we've saved this stock, undo that change, and that the thing that we load should be a stock list with the items inside it, which is the thing we're calling stock up there, and the last modified should be instant now because that's what we chose over there. Reformat that a little bit and run that. This still doesn't pass, and it doesn't pass not because the types are wrong now, but because now is subtly different when we run this code here from when we run this code here. So you see these are different by a few milliseconds. So we obviously have some sort of problem. So let's solve that problem by passing this time here into this, because this is our default last modified, if you like, if we don't know what else we could use. So this is going to be default last modified. So much stuff popping up. Find, which is going to be an instant. And most of our production code can quite happily use instant now when this was called, but we want to be able to set it for our tests. And what we'll do is we'll just pull out a field in our test which we'll consider to be the fixed now time. So we'll say this is a private val. And if we pass that into here and pass it into here, making it clear that that is the default last modified, then we should have a test that passes. Because now these are the same time. Oh, I say it should, but of course we're not using it over here. So we should now put that, make that there. And that should pass. Splendid. Now we'll only use that default last modified if we don't have one in the file. So let's go ahead and write the last modified date from a stock list into the file itself. In order to do that, we're going to have a version of SaveTo that takes a stock list rather than a list of items. Let's just play with this a little bit. We'll rename this to be items. Now we have stock. And we'll pull this out as something to be used more generally in that test. This then is our legacy, if you like. It's what happens when we save without last modified date, which will be the files that we have saved so far. We'll call that load legacy, I think. And we'll duplicate that, which is a version, and this one will be save and load. Save and load. In this case then, we're going to need some sort of time, so we will say not item save to, but stock list save to. So we'll build a stock list. With now and our items. And we want to save those to the file. And when we read that back, we should get a stock list with this now, even if we sent in a different default last modified. So here we'll say, well, let's pretend that default last modified was now plus an hour or something. So if we run that, this will fail. We can get rid of that. In fact, this is a bit rubbish. What we should really be saying is let's create a stock list. Let's save the stock list to a file. And then what we get back should be the stock list that we put in when we load it. And that fails because we're using this default last modified here when we load the items, because we're not saving the time in the file. How are we going to save the time in the file? Well, I think we'll give ourselves a version of this which takes a stock list as its receiver, and as well as the tab separated lines, we'll write a header. So we'll say writer dot append line, and we're going to put in maybe a comment marker, and then something looks rather like a HTTP header, maybe last modified, with our stock list. So that would be this dot last modified. So that's going to end up in the file then, but it won't pass our test yet because we're not reading it out of the file. And in fact, worse, this has broken our reading code because our reading code is trying to parse this header line as an item, but it's not an item. So we're now going to have to work out how to return a stock list from here. So what we're going to do is we're going to take our lines and we're going to partition them at the line that starts with hash. And all the lines that start with a hash are going to be in our header, and all the lines that don't start with a hash are going to be in our body. Now our stock list will work over the body, but we can get our last modified out of the header if it's there. So simply, and without any error handling, last modified is the header dot the first line in the header, and we're going to take the substring of that from the length of this string here, irritatingly without that length, and we're going to parse that as an instant, and we can pass that in here. Now that causes this test to pass but our other test to fail. Why is that? Well, in the case of our load legacy file, we have no header, so we're going to have to account for that. How are we going to account for that? Well, actually, if there are no headers, then this header will be empty and first will fail. So we could do a better stab by taking this thing as a variable and say that is first or null. Now this will force us to consider the case of the null, and let's just write it out simply. Last modified is if first is null, then it's our default last modified, else we're going to parse it with instant. So I don't know how to form that properly. It's not going to live. Important thing is to get the test passing, and this does. Now we can mess around with let to make this a nicer expression, but actually what I'm going to do is I'm going to add a little extension method here, which is to instant, and you'll see why in a minute. So that's just private in here, and this is going to be instant.parse. IntelliJ seems to be making some very strange decisions. This. If we do that, then we can now take this and do toInstant on it. Run that and we'll see it's the same code. Pass its test. Now we can simply chain these together so that last modified is header dot first or null question mark dot substring question. Oh, what happened there? Question mark dot toInstance Elvis default last modified. And we could probably lay that out a little bit nicer. So we're taking the header, we're taking the first or null. If that is not null, we'll take the substring, if that's not null, we're taking instant, otherwise default last modified. It's a little bit ugly, but let's pull that out into last modified from. And arguably, it would be nicer if this didn't take this parameter, but we would say last modified from header, otherwise default last modified, should be question mark colon, and allow this to return a nullable. That simply needs that, I think. There we go. Okay, so arguably this isn't really pulling its weight, so we can inline it. And that's not a bad formulation, I think. What we should probably do, this load legacy file, here we're saying items saved to file. We should probably pull this list of items saved to file over into the test code because it is our legacy. The old way of doing things, we don't want it in our production code, so we'll move it over here. But in order to do that, we need to make this internal. Arguably though, again, because we might change our format, we should probably save this as the old way of doing things as well. So let's copy that line, move it over here. And in fact, we can put it into here, keeping everything nice and neat. So that still pass the tests. It does, and now we can rename this to be legacy SaveTo. As we see that, though, I'll make that private for the tests. We could see that in fact our load and save empty was using the legacy version, so let's just fix that as well. So this will move up because it's part of our more important tests. We can also, it should be really save and load, but we can rename that with the spaces, and then we can say this should be save and load empty. And in this case, what we want to do is we want to not do that. We want to say that we have some sort of file. We say we want val StockList is a stock list of now and empty list, nothing in it. We want to save that to the file, but with the StockList version. And then when we load that, we should get back our previous stock list. And just to be sure that we aren't cheating, again, we'll set a default last modified to be now plus seconds, which pleasingly passes the tests. Now we might want to do better error handling, and if we do, it's a bit of a pain that we keep on loading and saving to actual files or having to do this temperature everything. So what we're going to do is, as well as this save to file, we're going to have StockList return the sequence of lines so that we can save them. What would that look like in the case of SaveTo? Well, what we want is a sequence of lines that is a sequence, and the first line will be the thing that we're putting out as a header, and the other lines will be taking our items and mapping them with this it.line. If we had that, then instead of taking this buffered writer and appending lines to it, we could take the lines, and what we're going to do is we're going to say lines dot for each. So for each line, we're going to say, it's a bit rubbish, but writer dot append line the item, where the item is not the item now, it is a line. So that will work out the same code, because what we're doing is we're calculating what the sequence of lines should be, and then we're iterating over it and putting them out. And this allows us to create a function here, which is 2 lines on our stock list. And then we can inline that. And we can inline that. And we can make this a single expression. So now stock list to lines is a simple value. It's a sequence, we can argue may or may not be a value. But we can use that, for example, over in load and save empty. If we're going to, though, we need to be able to load from a sequence of lines. And as it happens, that's what the body of this thing is. So if we were to take, because this lines here is a sequence, so if we would take this and make a method out of it, or a function out of it, then this would be to stock list on a sequence of string. So we'll make that the receiver. Okay. Why is that helpful? Well, this load items becomes very simple. It's just taking a sequence of strings. Save items become very simple. It's just returning a sequence of strings, and we can join the two up in here. So instead of having a file here, we could say, here's our stock list, and we could say, instead of saving it to a file, we can say, get rid of that, and now stock list dot, the stock list will be what happens if you take the stock list and you do two lines on it, and then take those lines and pass them back into a stock list, giving it the default last modified. And this is only spoiled by the fact that we cannot call that. So now we've got a nice interface in terms of primitives sequence rather than a file, so that this doesn't need that file parameter. Why is that helpful? Well, now that we don't need to put things into a file to read them in, we can create sets of lines that are malformed in some sort of way and see what our code does and write the error handling code. So for example, what happens when we already know what happens when we don't have a LastModified header, because that's our load legacy file. But what happens when we do have a header but we can't parse it, or we do have a header but it's not LastModified? So let's take this test and duplicate it. So this would be load with no last modified header, and this is to say we've got some lines and it's just a sequence of, say, a header of banana. And the question is, what happens if we take those lines and we pass them to stock list? What will we like? Well, I think we'd like it that in this case we have a header, but it doesn't claim to be our last modified header, so maybe we should take the default. So this should be a stock list. Well, that should be this stock list as it happens, providing we pass in a default last modified of that. So let's see whether that works. And it doesn't. Why doesn't it? Well, looking down through here, it's because we're taking the first item out of our headers and assuming that we can do substring on it. So let's fix that by, instead of doing first or null, we will make this into last or null matching a predicate. So we can find the header that matches last modified, and that is it.starts with last modified. And that helpfully passes. What will we have a last modified header but it's blank? Well, we can now simulate that. So that will come load with blank last modified header. So this is last modified. That's a header, but it's blank. What should we do in this case? It doesn't seem reasonable in this case to use the default because we have a header, it just doesn't have a value. So we have to decide whether to throw an exception. I think we probably should throw an exception because this means that this file is malformed, and if it's malformed, then all bets are off, really. So what we'd like in this case, well, let's find out what we actually get. So what we actually get in this case is this string index out of bounds because we are trying to take out that many characters. We can fix that a little bit, I think, by maybe substringing and then trimming. That will allow us to have a space or not have a space. And then finally, the problem here is that toInstant is going to fail because we're trying to parse a blank string. So let's write in our test what we actually want to happen here. What we'd like is some sort of exception. So these are our lines. We'll say try. We're going to try to parse those lines to stock list with some default last modified. We're going to catch some exception. This is a point at which we can specify what we'd like. I think maybe let's go with IO exception, shall we? And given that what we'd like is an IO exception with a message, we'll work out the message in a minute, will be the x.message. So take that out. This test will fail because we're not throwing IO exception. But if it doesn't throw, in this case, we should fail. There are other ways to assert on exceptions, but this will do. So let's use this string to instant to throw that exception. So here we can say this is going to be, we'll try to parse the instant. We'll catch any date time parse exceptions. So what we're actually seeing. And if we get one, we will throw an IO exception with the message of the date time parse exception. Message, and we will put a prefix on that of parsing, could not parse date header, not parse, we called it last modified header, colon, and then our message. We'll see what we actually get out here and see whether that looks good enough. So we expected could not parse last modified. We expected nothing, but we actually got could not parse last modified text. Could not be parsed at index 0. I think that's good enough. It tells us what our header was. It was blank in this case. So let's take that and say that's what we would like our message to be. And armed with this, we can play whatever games we like with malformed input. But I think this is good enough for now. Should we throw an exception, or should we have some other way of identifying what went wrong? That I think we'll throw an exception for now, but we'll probably come back and look at error handling later on in this series. As usual then, the last little tidy up, we will try and make our public interface at the top. So we've got StockList to lines and StockList save to file. Those are both our fundamentals. And load item, so this StockList line can go down. These are our private little functions. Last modified from, string to instant, and string to item. Those are all. But finally, our StockList needs to come out of here and into its own file. So com gilded row StockList refactor. Add that to Git. Make sure everything passes. Splendid. This isn't wired up yet. I mean, it's wired up in as much as we know that it will be used to load from disk when we run up our server. So let's just make sure that works by running main with our old version of the file, which doesn't have a header in it. And lo and behold, we can load that file, which is good. It shows that we can load a legacy file. Okay, I think that will do for today. I'll save you the pain of checking it in. But just to review, we have managed now to load our old files and also load a new version of the file that has a LastModified header in it. And we've handled error handling and so on. I hope you enjoyed this. If you have, you'll probably enjoy Net Price of my book, which is called Java to Kotlin, a Refactoring Guidebook. Tune in next time for the code where we actually use this to update our stock list, knowing now when it was last modified.